I first heard about microplastics in 2012 and a light went off for me. I couldn't believe that the waters that I grew up on and lived on were filled with plastic. So I set out to figure out where that plastic was distributed, how much plastic was in the waters.
There is a common theme to all of the expeditions that I do, and the equipment and gear that we have absolutely cannot fail. It has to work at optimum performance. That's where the Dell rugged technology comes into. The Dell machine learning technology is also here with us. It's performing at an optimum level. This is the first time that science and machine learning technology has synergized in Antarctica.
Microplastics isn't just a marine species and food web issue, it's a climate change issue.
I started using and testing Dell rugged technology for about 7 years now. I've taken Dell rugged to the deepest jungles, to the hottest deserts, to high altitude, and it has worked optimally. And now we're at the hardest place to get to, the harshest environment here in Antarctica, and this is really the ultimate test for Dell rugged.
We are out here collecting the microplastic samples to build the model for our future algorithm.
Josh recognizes the potential of the machine learning and has the technological skill set to facilitate this data capture with Abby.
We are machine learning species of penguins, seals, whales, and other environmental changes.
He comprehends what this machine learning technology is actually doing. He understands all of the 360 video and VR that integrates into machine learning, that connects with the rugged and Dell devices and the gateway device. It's literally the cutting edge of science and technology coming together in hopes of making the world a better place.
For doing field work, you have to be prepared to be rained on, snowed on, be walking through penguin colonies. Using Dell Rugged in the field has been incredible. It can get dropped on rocks, it's been snowing on it. It's totally indestructible.
We got 64, 32, 37 south, 63, 11, 55 west.
Time?
Time is 8:36.
By understanding the data that we're collecting with Abby,
All right.
taking the air samples, the water samples, we are understanding what we're actually able to achieve in the field. We're conducting research in an unpredictable environment. The equipment needs to work and endure these conditions.
We've been trying to get good weather, but we got hit by some crazy storms. We kind of shifted gears from the east side of Antarctica over to the west side of the peninsula. But the challenge is the weather and conditions and still being able to work every single day, no matter what the weather does.
All right, we're here to take a water sample. And I'll take air temperature, wind speed, wind direction, and salinity.
Beautiful morning once again out here among these thousands of chinstrap penguins, and we're using this Edge gateway device. This is allowing myself and Josh to really do this machine learning and edge computing, from facial recognition with penguins to the microplastics research to different iceberg shapes. We're really trying to push the edge of technology and what's possible.
Being able to depend on the gateway to connect so many dissimilar devices has literally saved hundreds of man-hours.
Being able to utilize technology and AI right here at the edge on site with us in Antarctica means that we can get more value from our data right here as we're collecting it. With edge computing, we can direct our research, make decisions, and utilize our time more efficiently.
Since this is the first of its kind research on the Antarctic Peninsula, I was so eager to plug in my microscope and have a look at those samples. So during the course of this expedition to the Antarctic Peninsula, we were able to take 18 samples here on board the ship. We were able to collect 38 air samples, 27 surface water samples, and we took 9 field blanks, which is really important for this research to make sure that our sampling gear is not contributing to microplastic contamination in the filters.
As Abby's doing her science, Josh is doing the machine learning. If I can bring those stories back and share these with people and they can feel the emotion, I really think that's a big part of the teamwork to change our planet, to get people to care.
Plastics are running awry, and unless we do something now, we really are going to have a much larger pollution problem on our hands. All of our little actions to stop plastic consumption add up and can create a tidal wave of change. And change is absolutely imperative now if we don't want a future choked with plastic pollution. There's no reason to wait any longer.